afternoon and good evening to all of you whenever you are watching the video. Okay, we have already completed the aromaticity in the last class. So the today's topic is the types of reactions. Okay, what kind of reaction is there in the organic chemistry? Okay, so before dive into the types of reaction, we need to know some basic things. Okay, or some basic terms you can say. If you don't understand these things, you can't understand the type of reactions. Okay, so let's go dive into these things. Okay, first thing is attacking reagent. Okay, what kind of attacking reagent is there? Before going into this, let me introduce a basic thing of about the organic reactions. Okay, so if you see about the any kind of reaction, so there is a reactant, and the reactant is reacting among itself or with the reagents. Okay, and this one is forming a product. Okay, so all kind of reaction is going on like this. Okay, so in the reactant and reagent, there is something called attacking reagent. Okay, see, this one is reagent. Okay, so which one is reacting or which one is the more like what to say? See, there are three types of attacking reagent, which is one is electrophile, another is this one is free radical. Okay, free radical and nucleophile. Okay, so what are electrophile, what is nucleophile, and what is free radical? Okay, so we'll understand what is the electrophile, nucleophile, and free radical. Okay, so what is electrophile? If you break down the words, okay, so this one is the, see, this one is electro and phile. Okay, so electro, it means electron, and phile, it means to love. Okay, it means the species or the molecule which loves the electron. Okay, so see, electrophiles are the electron deficient species which can accept a pair of electron. It means, see, a person who doesn't have money, okay, and he is hungry. Okay, let's say a person is hungry, so that person needs what? Obviously, he needs food. Okay, so he is deficient for food. That's why if he or she see foods, okay, so that will attract, okay, towards the food. Same thing is here also. Electrophile are the species which having deficiency of electron, and it love to go with the, it love to accept the electron. Okay, it loves to attract the electron. As a hungry person is deficient for food. Okay, it means it that person will love to eat or food. Okay, same thing goes here also. Let's say I'm taking an example of H plus. Okay, so this one is a species. Okay, so it has a deficiency of electron. Okay, so it will love to accept electron. Okay, I hope you understand. Now see, electrophiles are most probably positively charged. Positively charged, it means if a molecule lose electrons, then that molecule get the positive charge. Okay, it means that molecule is having electron deficient. Okay, so H plus, NO2 plus, this one is CH3 plus. Okay, so these are electrophiles, and some more examples are these. Okay, see, PCl5, SO2, SO3, BS3. these are also electrophile. Why? Because the central atom of that molecule is having a vacant orbital. Okay, it means, see, if I take an example of money, okay, so if you have some money and you have some space for keeping that money, okay, so then also you can accept the money. Okay, see, one thing, see, we have many type of people in our society. Okay, one is, let's say, person A, person B, and person A is having a deficient of money. Okay, person B is neutral. It means the person B have sufficient money. Okay, and B is satisfied with this. Okay, and C is having neutral money but not satisfied. Not satisfied. Okay, so it means it has sufficient money, it can survive, but it has some space also. And not satisfied, it means it has a desire of electron, it means it has a desire of money. So it can also accept the electron, or here in this example it can also accept the money. Okay, so same thing goes here also. Some species are like PCl5, SO2, SO3, BS3. These are the species which having a vacant orbital. Okay, where these species can accept the electron and keep it there. Okay, I hope you understand. Let's move. Okay, now what is nucleophile? Now see, nucleo, it simply means nucleus. Okay, and phile, it simply means what? Love, to love. Okay, so the species which love the electron, okay, sorry, love the nucleus, and phile, it means to love. Okay, it means a species which are richer in electron, it means that a species having more electron. Okay, so that species will go to the nucleus. Okay, let's say a person having lots of money. Okay, if a person have lots of money, okay, excess, okay, so that person will do charity. Okay, and for charity that person will go to what to say, either temple, church, or any non-profit organization or NGO, you can say, for charity. So these are the nucleus. Okay, if you compare both things for better example, I think it's a good example. Okay, so see, let's say this one is a species, and this one having lots of money, it means excess electron. Okay, so if this species having excess electron, so he have to donate. Okay, donate or give charity if you compare with the money. Okay, so for charity or for donating, he have to go where? Temple, church, or any NGO. Okay, or any like that, any places where you can donate. Okay, so all these center is nucleus if you compare both. Okay, I hope you understand. Now see, nucleophile having excess electron, it means it should be negative. Okay, negatively charged, most probably, mostly it will be negative charge, but it's not necessarily it will be negative charge. Okay, if you see the previous one, what I told, that the most of the electrophile will be positive charge, but it's not necessary that the all electrophile will be positively charged. Same thing here also, the nucleophile will be negatively charged, but it's not necessarily that all the nucleophile will be negative charge. Okay, see, this one is Cn minus, OH minus, Br minus, I minus, NH3. See, NH3 is neutral, water is also neutral. Okay, so why this one is giving electron? Okay, we'll just understand. Let's see. Let's take an example of NH3. Okay, so here is nitrogen, and nitrogen having how many valence electron? See, the atomic number is 7. If you write the configuration, you will get the 1s2 and 2s2, 2p3. Okay, so this one is the outer shell. Total 5 electron is there in outer shell. Okay, so see, 3 hydrogen is there. Okay, 3 sigma bond. So 1 electron is here in these 3 bond, and 1 lone pair will be there. Okay, so a structure of NH3 will be like this. Okay, so if you count the number of electron, here is 1 bond. So these 2 bond is common between hydrogen and nitrogen. So you can, it will be counted for octet for nitrogen also and hydrogen also. Okay, so hydrogen needs doublet. Okay, and nitrogen needs octet. Okay, so if you count 2 here, 2 here, and 2 here, 6, and this one 8. So total 8 electron is there. Okay, but the lone pair is extra. Okay, so it can donate the lone pair. Okay, so that's why this one is a nucleophile. Okay, now if you see water, H2O, so same, if you write the configuration, it will be 1s2, 2s2, and then 2p4. So outer cell, it means the valence electron is 6 electron. Okay, so here it will be 2 bond will be like this. Okay, and then 2 lone pair. Okay, so 4 electron from here and 4 electron from the bonding. So octet is completed, but extra 2 lone pair is there. It means it's a excess of electron, so it will give the electron. Okay, I hope you understand. Now one thing is MB file. Okay, so what is MB file? MB, it's a mixture, you can say, a single species having both quality. Okay, MB file, it means it's a act as a nucleophile also and electrophile also. Okay, so the species which love or which attract the both electrons and as well as nucleus also. Okay, so it means a species will have 2 atom or 2 kind of center. Okay, so one will be electrophilic center, another will be nucleophilic center. Okay, what is electrophilic center and nucleophilic center? Okay, let's take an example of CO. Okay, so C double bond O, and see this one, this carbon is forming 2 double bond. Okay, with the oxygen. So here is 4 electron. Okay, now it has 2 electron is left. Okay, so what will do? See, oxygen is also participating in the bond formation in which 2 electrons is involved. So here also 2 lone pair is there. Okay, and here it might be forming 2 bonds. Okay, one bond will be left and 1 bond. Okay, so I'm just talking about the CO. Okay, so here will be 2 electron. Okay, so see, this one is comparatively deficient. If you compare, here is 4 electrons and here is 2 electron. So carbon is having 6 electron only. So here octet is not completed. Okay. So octet is not completed, it means the carbon is deficient part. Okay. So if deficiency is there, it means it will act as a electrophile. Okay. So the carbon is electrophilic center. Okay. Now oxygen is having 4 and 4, 8. Octet is completed and 2 extra lone pair is there. It means it can donate the lone pair. Okay. So it will be nucleophilic center. Okay. Now same thing is here also, carbon and nitrogen, sorry, cyanide. Okay. So C triple bond N. Okay. So nitrogen having how many? See, 5 electron is there in valence shell and 3 is here participating in the bonding. Okay. So 1 electron is here. So 3 bond is formed here. It means 6 electron from here and 1 electron from here. So 7 electron is there with the carbon. So carbon is still deficient. Okay. So the carbon will act as a electrophile or electrophilic center, and nitrogen, see 6 here and 2 here, 8, octet is completed and lone pair is here. So this one will nucleophilic center. Okay. So it can donate and this one will accept the electrons, donate the electrons. Okay. Now let's move. Now another is free radical. What is free radical? See, let's say here is a bond between 2 carbon. Okay. And this bond can be broken as, let's say I'm giving this one C1 and C2. Okay, so I'll be writing like this. C1 is having plus, C2 is having minus. Another possibility is C1 is having minus and C2 is having plus. And third possibility is C1 and C2 both having electrons. Okay, why I have written like this? Because see, if in anywhere bond formation is there, it means there is a participation of 2 electrons. Okay, 2 electrons in which 1 electron is from the one atom, another is from the another atom. Okay, so equal participation of electron in the formation of a bond. Okay, so 1 electron is from the C1 and 1 electron is from the C2. Okay, so these two are heterolytic. Okay, and this one is homolytic. Okay, so homo and hetero. Hetero means what? Different. Okay, different, it means in this case there is equal participation in the formation of bond. So carbon 1, it means C1 have taken both the electron and this one is the second case. That's why the C1 is having negative charge and C2 is having positive charge. Just reverse in this one. So C1 is having positive charge and C2 is having negative charge. But as 2 bond is formed, like equal contribution of electron. So if it detach also, if break the bond with the same contribution, it can say, so similar thing. So 1 electron with the C1 and 1 electron with C2, it will be detached, or after breaking the bond, it will be 1 electron with carbon 1 and 1 electron with carbon 2. Okay, or you can say 1 electron with atom 1 and 1 electron with atom 2. Okay, so here the electron with the atom is there after the homolytic cleavage, so that is known as free radical. Okay, see, free radical are the electron deficient species with an odd electron around an atom. See, here is 1 is odd number. Okay, so this one is a free radical. Okay, now see, here is a single electron. It means, see, if it was in the bond, so both the electron was common for both, so the octet may be completed. Okay, now it's a detached or it's broken, so this carbon having one less electron as compared to the previous. So there will be the deficiency of electron. Okay, the same thing is here. Now these are some examples. Okay, see, these are some typing error. Okay, so CS3 free radical, C2H5 free radical, C2H5O free radical. This free radical is on oxygen. Okay, and this one CS3COO, and this one is also on oxygen. This one is on X etc. Okay, I hope you understand. Now let's move into the let's discuss some question. I hope it will be easier for you. It will be easy to understand. Okay. Okay, so I'm giving you some species. You have to identify whether it is electrophile or nucleophile. Okay, so first is OH minus, second is Cn minus, third is R3C minus, and D is H2O. Okay, and then H plus, X minus, then R3N. Okay, E, F, G and H. Okay, let's solve these things. Okay, see, OH minus, already here is negative charge. Okay, so it will be excess of electron, so this one is nucleophile. See, nucleophile is denoted as Nu minus also. Okay, whether the nucleophile is neutral also, then also you will be denoting like this. Okay, now see, Cn minus. Okay, so Cn minus will act as what? Nucleophile. Okay, because negative charge is there. Okay, so this one is also nucleophile. Now R3C minus. Okay, so carbon is having R 3 bond, and here it's a negative charge. Okay, so 6 and 2, 8 octet is completed, and negative charge it can donate to other. So this one is also nucleophile. Next is water. So this one is neutral. How you can analyze that this one is nucleophile or electrophile? So oxygen is forming 2 bond. Okay, so oxygen is having how many? See, I already discussed just before now. So it has 6 electron in the valence shell, so 2 electron is participating in the bond formation. Okay, and there will be 2 lone pair. Okay, so total octet is completed, but it has extra lone, it means it has 2 lone pair, so it can donate. So this one is also a nucleophile. Okay, now let's move here. So H plus charge, it means this one is deficient. Okay, so this one will be electrophile. Okay, see, E minus, see, a small e minus, it means electron, and capital E minus, it means electrophile. Okay, now see, X plus, this one is also deficient. Okay, so this one will be what? Sorry, it will be E plus. Okay, E plus. Okay, now see, X minus, so here is extra electrons. Okay, so it will be what? Nucleophile. Okay, now R3N, so nitrogen is having 5 electron in valence shell. Okay, so it will be like this, and it has 1 lone pair, it can donate, so this one will act as a nucleophile. Okay, now note down. Now see, I'll just give you a different type of question. You have to identify, I'll just give you the species which are what to say, amphiphile. Okay, amphiphile, and you have to identify that which part of that species is electrophilic center. Okay, so the first one is CH3 C H double bond O. Okay, and B is CH3, C triple bond N, and C is CH3I. Okay. Now let's see. If you see here, this one is CH3. Okay. So it will be like this, and then C double bond O. Okay. So here this carbon is having how many? 1, 2, 3, 4, 5, 6, 7, 8. So octet is completed. Okay. You have to identify the electrophilic center. Okay. So electrophilic center will be which one? Here is 2 lone pair. So oxygen is having extra. Okay. So this one is not deficient. Okay. So here is a pi bond. Okay. Which can be break. Okay. So it can be break. So this one, this carbon, see, if you see, I have given you an example of MB file. It was CO, okay, C double bond O. If C double bond O is there, it means that one will be the MB file, and that one, the carbon is the deficiency here. On the carbon, it's a deficiency. So the carbon in this compound is a electrophilic center. Okay. Now this one, if you see, this one is a cyanide. Okay. So cyanide is attached with the CS3. Okay. So in case of cyanide also, we have already discussed that the carbon is the what? Carbon is electrophilic center. Okay. Now this one is a bit twist. Okay. If you see, this one is CH3 and I. Okay. Now if you see here carbon, and if you compare the carbon and iodine, which having more electronegativity. Okay. So if you break this bond, okay, so iodine will go from here with the as a I minus, and here it will be left behind as a CS3 plus. Okay. So it means that there is the deficiency on what? Carbon. Okay. And iodine is having more electron. Okay. So the carbon here, it will be, the carbon will be here E plus center. Okay. Okay, now let's move on the next. So now we'll discuss the type of reactions. Okay. See, there are total 3 type of reactions only. The rearrangement is not a type of reaction. Okay. It's a part of reaction. Okay. So we'll just discuss these 3: substitution, addition, and then elimination. Okay. So let's move. What is substitution reaction? See, substitution, it means there will be a replacement. Okay. If you see, this one is a pink some atom. Okay, it's just representation. This one is pink one. Okay, and this one is a let's see. See, this one is a leaving group. Okay, and this one is the attacking group, and this one is whole is reactant. Whole all are reactant, and this one is the product, and this one is leaving group. Okay. So let's take an example. Okay. If let's see, okay, let's take an example of on the basis of NEET only. Okay. See, you have allotted a MBBS seat in let's say XYZ college. Let's say AIMS Delhi. Okay. No, not AIMS. Let's see any college in Delhi. Okay. Any college in Delhi. But now you want that you want any best college. Okay. As compared to this one which is allotted. Okay. So you came here. Okay. You taken admission there, and then you have tried to upgrade. Okay. Now if you want to upgrade, so if you leave this college, so someone else will come here. Okay. Someone else will come here, and that that person or that student will take admission there on the place of you. Okay, same thing is here also, but here the initial thing is the attacking part. Okay, see, this one is college with student. Let's stay, okay, just leave, I'll not take any name. Okay, so, and this one is the, let's say this one is a student 1 and this one is a student 2. Okay, now the student 2 wants to come into this college. Okay, and now the student 2 having a good score as compared to 1. Okay, so this student 1 have to leave the college, then only the student 2 can come. Okay, because the seat is limited. Okay, same thing goes here also. Okay, so the next thing will be after leaving this one, so this one will be as a leaving group. Okay, and now the next will be, next stage there will be the college with a student 2. Okay, okay, now see the proper example. Okay, see, this one is CH4 and this one is Cl2 in presence of H nu. H nu is the heat. Okay, it's giving CH3Cl. Now see, this one is carbon is having 4 hydrogen. The structure is like this. Now see, Cl2 wants to come here. Okay, so for that purpose any of the hydrogen should have leave his position. Okay, so see, if the chlorine want to come here, the chlorine will approach to the carbon, at the same time one of the hydrogen will leave. Okay, so what will be happening here? See, so hydrogen will leave as a leaving group and chlorine here is Cl2. So Cl2, see, initially Cl2 will break like this. Cl2 will break like Cl plus plus Cl minus. Okay, and here the Cl plus will approach to the carbon, or okay, so this one will approach to the carbon. It means the student 2 is approaching to the college. So one of the hydrogen will leave as a H plus, because hydrogen is having less electronegativity as compared to carbon. So hydrogen will leave as a H plus. So on the carbon there is a excess of electron and the chlorine is having less electron. It means this one is a nucleophile and this one is the electrophile. Okay, so electrophile will come to the nucleophile and this one will form the bond and it will form the new compound, which is CH3Cl. So here is the replacement of hydrogen from the carbon with see here is the replacement of hydrogen with the carbon, sorry, with the chlorine. Okay, I hope you understand. Now let's move on the next. Next is addition reaction. Okay, see, there is a types of see, one is substitution. Okay, and one example we have just seen, that one is electrophilic substitution. Okay, the same thing is one is electrophilic substitution, one is nucleophilic substitution and free radical substitution. Okay, so if you see, let's see, I'm just putting the box. Okay, this one is the reactant with the leaving group. Okay, and E plus is approaching here. Okay, and it will give this one plus leaving group. Okay, now you are think that here is substitution. Okay, leaving group is leave the compound. Okay, due to the E plus is approaching to the compound. Okay, E plus, it means electrophile is approaching. So in case of electrophilic substitution, the electrophile will approach to the compound and leaving group will leave, and instead of that electrophile will attach. Okay, same thing goes here also. In this case, nucleophile will approach to the compound, okay, which having a leaving group, and here leaving group will leave and it will give like this. Nucleophile will attach with the compound and leaving group will just leave, okay. Same thing goes here also. See, this one is free radical substitution, okay. So in these two cases, one is see, both is heterolytic cleavage, okay. We have already discussed that what is homolytic cleavage, okay. So if homolytic cleavage is there, it means it will lead to further homolytic cleavage only, okay, not if the reacting, see, let's say this one is Cl free radical, okay. So Cl free radical will approach to the carbon, okay. So it will give the free radical only, the whatever the bond will break there. See, this one is leaving group, okay. So if it, this one will approach to the compound, so it will form again this one with the chlorine, and it will give the leaving group with the free radical, okay. It means on if free radical is there at the initial as a, which initiate the reaction, okay. So the all the stages, most of the stage, it will trigger, that one will be the free radical only, okay. It means there will be homolytic cleavage further, okay. Okay, now let's move on the next. Next is addition reaction, okay. What is addition reaction? Addition, it means this one is a compound, okay. So there will be some breaking of bond, okay. There will be some breaking of bond. There will might be a multiple bond, okay. So that multiple bond will break and the another compound or another molecule will attach to this one, okay. It means, let's say this one is the attacking group. It can be E plus it means electrophile, nucleophile or free radical, okay. It can be anyone, okay. So this one will approach to the compound, and then in the compound, inside the compound, there might be multiple bond. Multiple bond, it means either will be a double bond or triple bond, okay. So the double bond or triple bond will break, and then that compound which is approaching, that one will attach with the compound, okay. Now see, here is a carbon-carbon double bond, it means CH2 double bond CH2. Now hydrogen is approaching in the presence of metal, okay. So this one will approach as a H plus and H minus, okay. So this one will approach as a H plus and H minus. So it will be like, see, carbon is having double bond CH2 like this, no? Okay. So let's see, H plus is approaching here, okay. So carbon is already having 4 bond here also and 4 bond here also, okay. So you know that the sigma bond is like pi bond is more weaker as compared to sigma bond, okay. So pi bond will break here, okay. So if pi bond will break, so see, here is H plus is approaching, okay. So the carbon will have one bond like this, and one carbon will have negative charge, one will have positive charge. So here H plus was approaching, so H plus will, see, H plus is having deficiency of electron and this carbon is having excess of electron. So the H plus comes to C minus, and one more H minus was there in the solution. So that one H minus will approach to this carbon, because this hydrogen is having excess electron and this carbon is having less electron. So the species which have excess, that one will donate, and he will find the donor. It means he will find the species which is deficient, okay, and both will approach and form the compound, okay. So the final compound will be like this, CS3 and CS3, okay. I hope you understand, okay. Now let's move on the next. So same thing here also, the attacking group can be electrophile, nucleophile or free radical, okay. So same thing goes here also. there will be the addition of the electrophile or nucleophile or free radical. Okay. See, the previous I just have given the example of this one, the CH2 double bond CH2 with H2 is giving CH3 so H2 break as H plus and H minus, and H plus is approaching here. It means the H plus is what? E plus, it means the electrophile. So this one is the example of electrophilic addition reaction. Okay. Now see, next is nucleophilic addition reaction. You can say this one as a NAR. In short, this one is EAR. Okay. This one is FRAR. FRAR. Okay. Now see, what is nucleophilic reaction? You just write down this one. I'll just rub this part because I need some space for this one. Okay. Now see, I'm writing for nucleophilic reaction. Okay. So carbon is having double bond and with the oxygen, and HCN is approaching with this one. Okay. So see here, C double bond O, this one is MB file. Okay. And here the carbon is electrophilic center. Okay. So this one you can break like Cn minus and H plus. Okay. So what will be here? H plus is this one and Cn minus is this one. Okay. So what will be here? This one is deficient. Okay. So carbon is deficient. Okay. It means this one is a electrophilic center. Okay. So which one is having excess of electron in these two? H plus is already electrophile. So electrophile will not go to the electrophile. Okay. So nucleophile will come here. Okay. So what will be the reaction? The compound will be like, see, this bond will break. Okay. And here it will be like cyanide will approach to this carbon and it will be like this. Okay. Okay. So the product will be like this. Okay. It means simply you understand that if electrophile is approaching, it means you have to identify the nucleophilic center on the compound. Okay. Let me see. See, if you are doing the electrophilic addition reaction, okay, in that case you have to identify the nucleophilic center. Okay. Nucleophilic center, it means that the center which have more electron, so the electrophile can approach to that place. Okay. Same thing in case of nucleophilic addition reaction, you have to identify the electrophilic center. Okay. And again, next is free radical. Okay. So in case of free radical, it will approach to the like what to say, multiple bonds. Okay. So multiple bond, that one will break, and it will break as a homolytic cleavage, and it will give the free radical, and then the free radical part will approach to each other and form the bonds. Okay. Now see, in the presence of peroxide, this bond is break like this. Okay. It means it will give a homolytic cleavage. So H free radical will approach to this one. Okay. So H free radical will approach to this compound. So the pi bond will break. Okay. So it will give like CH2 single bond CH2, and both will have free radical. Okay. And hydrogen free radical is approaching to this carbon. So it will form a bond because here is free radical and here is free radical. So both will combine and form the another bond. Again, the Br free radical will approach to the another carbon which having the free radical. So again, here free radical, here free radical, both will approach, and then it will form CH2 Br, CH2, here will be hydrogen. Okay, so the product will be like this. Okay, I hope you understand. Now let's move on the next, which is elimination reaction. Okay, what is elimination reaction? Now see, this one is a complete compound. This one is a compound. Let's see, this one is the center part and this one is center part. Okay, so this one and this one will approach to each other. Okay, and both will leave from the compound. So it will have either positive or negative. Okay, or this one will have negative or positive, or you can say both will have free radical. Okay, so in all three conditions, it will approach to each other and form the another bond, which is pi bond. So the compound will be like this, and these two will leave. Okay, it can be forming another bond with these two, or it can be individually also. Okay, now see, this one is a compound. Okay, which is CH3 and CH2X. Okay, X can be chlorine, bromine, or iodine. Okay, if you heat with the alcoholic KOH, so this one will approach to this one. Okay, and it will form HCl. So X minus, see, this one is halogen, so it will leave as a X minus, and hydrogen will leave as a H plus. So if halogen will leave as a X minus, so there will be positive charge on carbon, and hydrogen will leave as a H plus. So on this carbon there will be negative charge. So this one is negative, this one is positive. So both will approach and it will form a double bond. Okay, see here, it's a double bond. It's a alignment problem. Okay, you just understand. Okay, so there will be the another compound as a HCl, which is leaving from the compound. Okay, so here is the elimination. Okay, so which one is eliminated? These two is eliminated from the compound. Okay, that's why this reaction is elimination reaction. Okay, now same thing will be goes to here also. Elimination reaction also has three kind of reaction. Okay, three kind of thing. One is electrophile, nucleophile, and free radical. Okay, now see, in case of electrophile, see, I have taken the previous example. That one was like this. Here is X. Okay, so see, hydrogen will leave as a H plus, and H plus is a electrophile. X minus is a nucleophile. Okay, so if electrophile will initiate the reaction, okay, it means the attacking part or the initial part is the H plus. Okay, so in that case we will say that this elimination is due to H plus. Okay, so H plus will approach to this one. Okay, in that case this one is a electrophilic elimination reaction. Okay, but another thing is, if nucleophile will initiate the reaction of elimination, in that case we'll say that the nucleophilic elimination reaction. Okay, and another thing is, if it will break like a free radical. Okay, so in that case we'll say that the elimination reaction is this one is a free radical elimination reaction. Okay, now see, what is rearrangement? See, rearrangement is the process of alignment, or see, it's basically done for the better stability. Okay, see, here is the example. Okay, this one is the C1, C2, C3. Okay, 1, 2, 3, and this one is a bromine. Okay, now if you see, this one is rearranged. Okay, if you see here, if Br will leave from here, it will leave as a Br minus. Okay, so here will be positive charge. Okay, and this carbon is having 2 alpha hydrogen. Okay, this one is alpha carbon and it has 2 alpha hydrogen. So, and if you compare this one, if here Br will leave, it will leave as Br minus, here will be positive charge. So there is 2 alpha carbon. This one is alpha carbon. Okay, alpha carbon, and both is having 3 alpha hydrogen. So total 6 alpha hydrogen is here. So this compound is more stable as compared to this. So the rearrangement is undergoing due to gain more stability. Okay, see why I have break this bond, because if you proceed the reaction, okay, there is a breaking of bond and the formation of new bond. Okay, so one stage is the intermediate stage. Okay, so intermediate stage should be stable. Okay, then only you can proceed the further reaction. Okay, for that purpose it should be stable enough to proceed further reaction. Okay, that's why the compound will rearrange itself for gaining stability. Okay, so that's all for now. Okay, thank you so much for watching the video. I hope you will do well.